Hello everyone, my name is Parikshit Chitalkar. I'm one of the co-founders at Stashfin. By way of background, I am an army kid, grew up all across the country. I have my professional experience, I have about 17 years of experience working in the technology space, largely around building cloud technologies in retail and financial services. Worked for many years in Canada and the US in the banking sector. And my role here at Stashfin since 2016 is to lead the technology as well as the data science vertical. Some background about Stashfin. We started in 2017. Our product is that we offer consumers in India a line of credit delivered through a Visa card. Consumers can withdraw any part of their line 24/7. Our product also offers free ATM withdrawals and a host of other features that services our customers. Stashfin is led by a team of professionals who have extensive working experience overseas. We are about 200 people strong, based out of Sultanpur in New Delhi. We've been in business for about 5 years. We have about 1.5 million customers at this point. We've seen some extensive growth in the last 24 months or so. All of this has actually been powered by a large technology platform that we have built in-house with our own engineering team, which will describe some of the gains and some of the challenges of that process today. One of the key components of our build out was to make sure that we have complete control over our technology stack, which is why we chose to build this entire technology platform in-house. And as the platform started to scale, one of the key considerations that we had was how do we organize our infrastructure to support that growth and scale. There was a couple of problems that we were dealing with, and I'll describe those and we'll talk about how we address them. The first issue is that we have a very large application footprint, followed by the fact that we have a huge amount of data streams that we consume on a daily basis. So just to give you a sense, if you imagine anything that a bank does, think about any bank that you bank with, any piece of software that a bank runs, we run that. So at the present moment, we have about 75 different applications in production that is managed and maintained and continuously monitored by our team. So that's a fairly extensive footprint that we need to deal with on a daily basis. Also, since we are in the underwriting business, we actually consume tons of data that comes across various data sources, right? From bureau to mobile footprints to banking. There's a huge amounts of transaction volumes. We're also integrated with the Visa and MasterCard switches directly, so the transactions also pass through our systems. So therefore, it is a big data problem. So we need to manage and maintain these data pipelines that have to be up all the time. They have to consume data, and they have to give responses real time as well. So these are the two major problems that we deal with. How we chose to optimize for those problems and how we chose to deal with them at scale is something that we'd like to describe here. So we started out by building a completely cloud-native infrastructure. Every single piece of technology that we run is fully built, managed, and maintained on the AWS cloud. For instance, we have a CDN. Our CDN and our DNS is run on Cloudflare, and then we use AWS CloudFront to direct traffic into our infrastructure. We use Istio as our ingress gateway. We use Keycloak as our identity server. And essentially, the philosophy being that all of the tools that we use are pretty much off the shelf. They're either SaaS products, off-the-shelf products that are very easy to integrate. Other people have done it. So we've just found interesting ways to replicate that in our own infrastructure. If you go to the dev environments, we are fully containerized. Every single piece of software that we write is in a containerized environment. We use Docker and Kubernetes. We've also built a fully automated CI/CD pipeline. So it's a multi-branch, multi-environment, Jenkins-driven pipeline that we'll use things like linters and test cases to automate some of the deployments. Right from our dev to our staging to our production environments. So idea being here that our philosophy was, let's not try to reinvent the wheel. These are all things that have been solved by multiple people before. So we just chose to use those pieces of technology and assemble them in a way that solves our use case and also allows us to scale. The tendency is always to lean towards managed services as much as we can. So all our databases are fully managed. We'll use Amazon EKS, things like that. So large sort of parts of our footprint are completely running on managed services. The second important piece of our puzzle was how to solve observability, especially at scale. So it's very important for us to, again, one of the key components of our business is that we need to always optimize for costs, since we're in the business of money. So therefore, optimizing the number of resources that we use to manage and maintain our platform is actually very, very critical. Therefore, we use tools such as Grafana and New Relic to continuously monitor platforms. These are integrated to our Slack channels. If something was to go down at any point during the day, our developers get notified. And we also have a process in-house where, for instance, in New Relic, we will actually look at the top 5 or top 10 areas which are either causing database latency or any type of issues, and we'll do a weekly sprint where we actually specifically optimize for those. So observability is a big part of our infrastructure. We spend a lot of time internally. I mean, in the teams, we have a saying that you can't fix what you can't measure. So that approach goes down to the leaf level developer, and we make sure that everything is in a format that if something was to break, there is an alert that's triggered somewhere. This also escalates right to our data structures as well. So for instance, if there is any type of data inconsistency, there's about 70 or 80 alerts that the analytics team has actually written on top of our data stores. So if a database lock occurs and a loan is stored in the database incorrectly, immediately there'll be a trigger that someone will get notified, and they'll be able to get in and fix it, or inform customer support to have the customer do some profile update on the application, whatever that may be. So the point being that observability is one of the key cornerstones of our infrastructure, and it has actually worked out very well for us because since we're able to observe all these problems and fix them proactively, it's allowed us to scale very effectively at a very minimal footprint. Sort of an organization our size would easily have a team of 15-20 DevOps folks who are sort of managing a system of 75 plus applications. You replicate that across production, development, and staging. We're doing that with a handful of folks. The third part of our infrastructure challenge was actually how do you build a data pipeline that scales along with you. So that was something that we embarked on that journey in late 2018 to revamp our entire data pipeline. The problem specifically within the data pipeline that we're trying to solve is we need to have real-time decisioning. So data needs to come in, it needs to be sanity checked, it needs to be consumed instantly, and then the entire data pipeline has to scale. So if I go from 50,000 customers to 500,000 customers, I am not in a position to retool this data pipeline on the fly. So in terms of our architecture, we use multiple data stores. We use Redis, we use MySQL, we use Redshift as our main data lake, and then we use flat file storage in S3, which we access using Athena. That's from an analytics standpoint, the last bit of that tooling, the S3 plus Athena, has actually worked out really well. So Athena actually gives us the ability to write raw SQL on S3, which is something that our data analytics team uses extensively on a daily basis, and they absolutely love it. With this infrastructure, what ends up happening is it's no silos. So it's a no silo infrastructure. There's a massive data lake that we manage in Redshift, and all of our processes, right down to our ETLs, analytics teams running raw queries, our Power BI reporting dashboard, all of that is accessed directly through that data lake. And then the data lake is enriched through other ETL pipelines coming from various sources such as bureau data, mobile, banking, transactions from the Visa and MasterCard switch. So all that is built on this sort of multi-storage infrastructure that has allowed us to scale over time. So the idea being, with the efforts that we've put in terms of building this cloud native infrastructure that scales, building out, a high observability environment, building out this robust data pipeline, what does that actually get us? Because we're very clear internally that we are a financial services business assisted by technology, not a technology business that also does financial services. So therefore, it's very important for us to boil this down to a metric that is meaningful to the business. So as a result, over the last 5 years, what we've been able to observe that our throughput in terms of the amount of volume that our system services has actually grown many folds compared to the number of headcounts that we've added on the developer side. We've seen similar results on our AWS or our cloud costs as well. Our costs, especially in the last 2 years or so, we've optimized a lot. Our costs have remained fairly stable, and the business has literally grown 100x at this point. So one of the key components in how we actually do this is these are the metrics that right down to every single engineer would be aware that this is what we're optimizing for. That clarity of thought really helps us build tools and technologies that serve a common purpose. So this actually brings up a very important point, which is a key to our success as an organization. We think that every problem ultimately is a people problem. This needs to be addressed by setting up the right culture, and I would attribute a large part of our success to the team in terms of how they've come together and how they've sort of built it. I'd like to highlight some areas of what we have specifically done, what we specifically observed, and hopefully those learnings help others as well. So the first thing that we do is we make sure that we understand what the goal of every single task is. What are you doing? Right? If I look at it from a people standpoint, we identify very early if this person has or we actually help them identify very early. Do you want to be an individual contributor who wants to become a technologist, or do you want to be a leader? Both have slightly different paths. There is a degree of overlap, but we'll kind of treat those individuals and give them roles and responsibilities within the team a little differently. And that also goes into this whole culture around learning. So if you look at our office, our technology team literally sits in the middle of the business teams. A lot of people may argue that it's different. People don't do that. Technology teams typically operate in a silo. However, the way it has helped us is every single one of our developers is very, very aware of the nuances of the business. So therefore, what ends up happening is that as an engineer, you already understand the tooling, and once you understand the business, you're able to come up with a solution that a business user alone would never have thought of. So therefore, this culture of constantly learning, doing weekly tech sessions, hackathons internally, interacting with other teams in the business, that's actually helped our developers grow very, very rapidly. Also, what we focus a lot on is that we keep continuously exploring new methods, new tooling that will help people become more efficient. And the culture internally is let's get better every day. Let's make new mistakes. Let's not repeat the mistakes that we made yesterday, because if you work, mistakes are going to happen. Then one more thing that we actually look at, where I spoke earlier about relying heavily on managed services. The culture thought process behind that is that we try to keep it very, very simple and try to keep everything very cross-functional. So reduce the number of components that you're using in a system. Centralize as much as you can. So you don't build something in microservices just for the sake of building it in microservices. There are some things that are actually if they're better served by a slightly monolithic type structure, we'll actually go ahead and use that. Don't refactor or rewrite just for the sake of it. If something's well written, something's stable, it's observable, it's working, it's scaling, there really isn't a need to revamp something just for the sake of it. Then another area that we spend a lot of time is we actually leverage our partnerships in a very, very deep fashion. For instance, AWS, New Relic, Cloudflare. A lot of people think that these are just platforms that are fairly opaque, and you use the service, you consume it, and you move along. That's actually far from the truth. If you look at our office, you'll see folks from AWS or Cloudflare here very, very regularly. We'll explore very deep partnerships with them, especially on the machine learning side. AWS has actually helped us figure out some models that we have then gone and tweaked and deployed. So we spend a lot of time enriching our partnerships with. So we spend a lot of time enriching our partnerships with their teams, and it may come as a surprise to many that these folks are genuinely very helpful, and they have specialist business verticals that are actually looking to do this. So it's really down to a question of asking for this service, and it's available to you. Another area that we focus on is we have a culture of very high accountability and ownership. For instance, we have a process called, we call it internally, it's called PIA. So as I said, my background is from the Army. I'm born and raised there. So it's very similar to an after action report that someone would file in the Army. So it essentially means that if something you did went wrong and it blew up in production, you have to write about it. You have to document what you did, what you could have done better, what you would avoid going forward, what the financial impact of that mistake was, and then we actually discuss it as a team. We create a safe space where people can actually feel comfortable to own up to their mistakes, and the entire team learns from it. So that's actually helped us a lot. It's become a culture where observability became, so people start to own things, people start to observe and manage their own products, and they end up growing as developers. So thank you so much for spending time understanding Stashfin's fintech technology stack and how we built our infrastructure and optimized it. We are building out our team, we are hiring, so feel free to reach out to us. The email address is on the screen. We look forward to hearing from you. Thank you.